8.2, Example 4. In Example 4, we're going to look at other indeterminate forms. In the previous examples, we've noticed that 0 over 0 seems to be the common indeterminate form. In Example 4, we're going to look at what happens when you get a limit of infinity divided by infinity. So we're going to look at the limit as x approaches pi over 2 of secant of x divided by 1 plus tangent of x. So now what we're going to do is we're going to go ahead and try to use our direct substitution and see what happens. So if I plug this in, I get secant of pi over 2 divided by 1 plus tangent of pi over 2. And the easiest way to do this, to analyze this graph to really see what's going on, is to go ahead and graph both pieces. So the first thing I'm going to do is I'm going to graph secant. Well, if we graph secant at around pi over 2, it's going to look something like this. And if we graph tangent at pi over 2, well, 1 plus tangent of pi over 2, it's going to look something like this. So if we look at this graph, as we approach it from the left, we're going to get the numerator, which is infinity, divided by 1 plus tangent of pi over 2, which is infinity. So this is infinity over infinity. And if we look from the right, you get that this is going to go down towards negative infinity. And this one is also going to go down towards negative infinity. So that gives us infinity over infinity again. And if there's a negative, that's okay. We could just factor a negative out. So when this happens, when you get negative infinity over infinity or infinity over infinity, we can use L'Hopital's rule. So we have the limit as x approaches pi over 2 of secant of x divided by 1 plus tangent of x. And by using L'Hopital's rule, we get that this equals the limit as x approaches pi over 2, and the derivative of secant is secant tangent, and the derivative of 1 plus tangent is secant squared. So doing a little simplifying, I'm going to rewrite this as the limit as x approaches pi over 2. 1 secant is going to cancel from my denominator. So I'm going to get tangent of x over secant of x. And just simplifying now, I get this is the limit as x approaches pi over 2. I'm going to write tangent as sine over cosine of x. And I'm going to write secant as cosine of x over 1. So my cosines are going to cancel off. And I'm going to get this is the limit as x approaches pi over 2 of sine of x. And then by doing a direct substitution, I get sine of pi over 2, which is equal to 1. So the limit of our crazy function in the beginning just turns out to actually be 1. Now on your own, I want you to determine the limit as x approaches pi of cosecant of x divided by 1 plus cotangent of x. My hint is to graph them, both the numerator and denominator, and see what happens from the left and from the right. Alright, so I'm going to go ahead and graph these. So I'm going to graph cosecant of x around pi. So here's pi over 2, and here's 3 pi over 2. So cosecant of x looks something like this. And then I'm going to go ahead and graph cotangent of x around pi. And this is going to look something like this, because it's 1 plus, it's been shifted up by 1. So now that I have that, we're going to go and we are going to look from the, let's start with the left. And so the limit as x approaches pi from the left of cosecant of x divided by 1 plus cotangent of x is going to be, well, as we approach from here, no, we're looking from the left. We're going to have infinity, and from the left, negative infinity. So we get that this is negative infinity over infinity. And now when we look from the right, we get this is the limit as x approaches pi from the right of cosecant of x divided by 1 plus cotangent of x, which is equal to, and from the right, we see that we're going towards negative infinity there and infinity there. So this is negative infinity over infinity, which gives us negative infinity over infinity. So that's indeterminate form. We get that this is the limit as x approaches pi of cosecant of x divided by 1 plus cotangent of x. And since we get infinity over infinity, we're going to use L'Hopital's rule here. And so this becomes the limit as x approaches pi. And the derivative of cosecant is negative cosecant of x cotangent x divided by, and the derivative of cotangent is negative cosecant squared of x. So just now simplifying with algebra, you get the limit as x goes to pi. The cosecant is going to cancel, so is a negative. So I get cotangent of x divided by cosecant of x. And again, rewriting that, I get the limit as x approaches pi. And this is going to be cosine of x over sine of x times sine of x. So this is the limit as x approaches pi of cosine of x. And so this is going to be cosine of pi, which is negative 1.